Hello everyone, Dave here. In this continuation on the NEP-5 contract, I want to go over how to implement the transfer method, which is probably one of the more complex methods to implement here. So to do that, I'm going to go back to our tutorial token here. I'm just going to paste this right from the website onto there, the method signature. So we have transfer here. So when the lowercase transfer method comes in, I'm going to call the transfer method here in uppercase because that's how I like it. And we are going to take in args bracket 0 will be the from, args bracket 1 will be the to, and then args bracket 2, not sure if I just said 0, 2, 2 here, but 0, 1, 2 will be the amount. Now you'll see we'll get errors because these are objects and the method is expecting bytes. This is actually a byte array. So I'll put that in there. Args bracket 1 is also a byte array, so we'll put that in there. And args bracket 2 is also a byte array, but we are expecting a big integer. So luckily big integer has an overload to it that will take a byte array in. So let's just plunk that in there. So now we've got that all wired up here. I'm going to put a return true at the end here because our transfer will be successful. So for a transfer in a NEP-5 token, we're going to adjust the value in storage here. So some people may think that a NEP-5 token is going to work like a blockchain, that we're creating something like Neo or Ethereum or Bitcoin or something like that. We're not. We're adjusting storage. We're running on top of the Neo blockchain here. And so the Neo blockchain provides us the security that we need, and all we're going to do is adjust storage on that blockchain. So we don't have to worry about transaction inputs and outputs and, cryptography and, all the different algorithms to prove the security, right? Proof of stake, proofs of work, the DBFT that Neo uses, those kind of things. So it's really quite simple here. We're going to start off and go away from balance equals balance of from bar to balance equals balance of to. So we're just going to reuse our existing balance of function here to pull the value out of storage. Then we need to adjust the balances. So from balance equals from balance minus amount. To balance equals to balance plus amount. So we're taking from one, giving to another. And then all we have to do here is update the storage. So storage.put. All right, we're going to use our current context from balance to balance. So all we're doing is overriding what's in the existing from key and the existing to key. So for these addresses, updating their balance. All right, let's build this and let us deploy it here. Copy the script hash, deploy, test, invoke, close. So we're going to have to wait a block for that to come up. Oops, I was hitting the wrong button here. So we do have a new block now, but it appears not to be in there. So sometimes you do get it in just as a new block has already generated but hasn't been alerted to the network that the block is in there. So now we're waiting 2 blocks here. Yay, there it is. So first of all, we need to deploy it to give the owner a balance. So let's deploy that. And we'll see here, this was from our test one, but we should see one pop in here very shortly that will have the deployment complete that actually ran on the blockchain. Getting slow blocks today, it feels like. Even though it's a local testnet and there's no load on it. But so we can call our balance of method, and I'm just going to grab the owner hash. And we can see here that we do have a balance here because a value is returned. Now, let us do a transfer here. So the first parameter is who it's from. The second parameter is who it is to. So what I'm going to do here for this first example here is just mildly change this hash to be someone else. So we're going to fire money off into the void. There's no one who's going to ever receive this token. And we want to send 1 token. But because there's 2 decimal places, 0, 0. So we're sending 1 with the 2 decimals on it. We do a test. We got halt break. Everything worked. You can see here that it was actually retrieving those balances. And then we can invoke it. So we got to wait again for that to happen. While we're waiting, I'm going to get that set up here. Oops, that was the owner hash that I pasted in there. Let's get the balance of I'm not sure if it's completed or not, but let's plunk this into our hex converter. There, now we get a different value. So if we analyze that, the balance of 999. So we did do a transfer here. Now I'm going to show you a fun little exploit we can do with this code. There's a few security vulnerabilities, but I will show you one of the fun ones and explain to you a gotcha of Neo here. So I'm going to send 1 token from me to me. So in a logical sense, I should deduct 1 off my balance, then add 1 to my balance, and everything should work out. I should have the 999 tokens. So test, do an invoke. Wait for that to go through. And I'm going to pull back my balance here. So hopefully a block has gone through. Okay, so this one has here. So remember, we should have 999. But what we actually have is the 1,000 tokens. So you think, do we have a problem with our logic? We saw the from and to work in our first example, but not in our second one where we sent to ourselves here. This is because Neo's doing something a little bit interesting here in that it's taking this from balance. It's going to start off at 999. And the to balance is going to start at 999. Then the from balance is going to be 998. And the to balance is going to be 1000. So we put into the from 999. And then we put into the to 1000. Because we've basically copied these items to variables and manipulated them, but we did not check that they were not the same. So in this case, from and to are the same. So a little bit of a hole in our logic there. So we can do some checks here, and let's implement a bunch of checks here. So the first thing I want to do is cover that scenario off that we just went over. If from equals to, cannot send to self and return false. So we are saying that is this byte array equal to another byte array? In C#, this is not going to work because this is not checking that the contents of the array are equal to each other. But in the NeoVM, it will actually check to see if they are equal to each other. So it's a little bizarre distinction. You can write a method if you want that does and sees, are these two reference equal? Are they the same object in memory? And then if they aren't, you can check the individual bytes to see if they are if you want. I'm not going to do that here for simplicity's sake. I'm just pointing that out that this is a little interesting gotcha in Neo. So we're going to say we can't send to ourself here. Another thing we don't check is who the from is. You can see when we created that transaction here in the Neo GUI that we just specified who the money was coming from. And we don't never check that that is the actual caller of this contract. That means that I could be anyone and say, well, from someone who has the owner tokens, the first 1,000, I'm going to say they sent it to me. And this would complete successfully here. So we need to do a little bit of a check here. So we can use that with the runtime check witness from. And we want to make sure that if it is not the case, I'm going to put a runtime.notify in here. They are not authorized. So here we're saying that the witness to the script, the invoker basically, has to match to this from address here. So now we've added a little security on that. Another thing that we haven't checked is the amount. Now, we're using a big integer, which is just whole numbers, but we don't check whether it's positive or negative. So if I were to send in here, I want to transfer from myself to this account minus 1 token, it would actually add a token to me, right? From balance minus -1, and then would actually withdraw it. So it's a reverse withdrawal. So amount is less than or equal to 0. There's no point to having a 0 value, so I'm going to put that in there, but you could say it's just less than 0 if you want. 0 should not have an effect, but invalid amount, and return false. The other thing we haven't checked here is to make sure that that this person actually has the funds. So here, and even we can, I'll keep that like that. If from balance minus amount is less than 0, insufficient funds. So I'm going to actually just move this 2 down here. I want this operation to exit with the lowest number of operations possible to keep the gas costs low. I know that you do get the first 10 gas free, but that's not guaranteed to be the case in the future. They could change that amount, say, well, now you only get the first 5 gas free, or the first 1 gas free, or no gas free. So you want to make these things run efficiently, just in case to try and future-proof your contract a little bit. Okay, so now we're making sure the sender is actually the sender, that the amount is positive, that the sender and the recipient are not the same person, and that the sender actually has the funds to transfer. So that's a pretty good list of checks here. The only other thing you may want to do here is check the length of the address here. So I'm just going to copy this into here, runtime.notify, and I'm going to say invalid from. And we're going to duplicate this for 2. Now there's a few reasons to do this kind of check, is that if someone's trying to manipulate your system, they may do it by sending in malformed from and tos. So by saying, by sending in a very large from, maybe they're trying to overwrite the to if you were doing some sort of concatenation later on. When we do the optional NEP-5 methods for the third-party transfer, I'm going to demo this attack. And if there are any kind of overflow attacks, maybe within the Neo VM where they can somehow overflow into another area of space, not super likely, I think, with the design of Neo, but you never know. So this is a good check to have in there. It does cost, extra operations to do this, but it does add some security to it. Okay. We're pretty close here. The last thing we need to do here is implement an event here. So I'm going to copy this event from the NEP-5 standard. I'm going to plunk it up top here. So it is an event called transfer. Lowercase t. We have a method here called transfer with an uppercase T and an action passed in with a transfer. So it gets a little confusing here. So I like to rename this here to call perform transfer, just to keep them a little bit distinct. And then all we have to do down here is if everything is successful, transfer arg1 is the from, arg2 is the to, arg3 is the amount. So what happens when we call this is that it's actually going to issue a notify message onto the blockchain that different systems can listen to and say, oh, there was an update to someone's balance. The reason for this is so that exchanges, wallets, and any other system you want to build can be aware that funds have transferred instead of constantly having to poll the account saying, well, what's your balance? What's your balance? What's your balance? What's your balance? If they watch for this transfer method, they can actually see if you have sent funds or received funds. So let us build all this. And now we get this fun error here, is that we get that it can't parse the type of action, basically, which is defined in MS Corelib, copy this DLL in. And it is really as simple as that. The Neon compiler, that's where this came from, is saying, I need mscorelib.dll in my bin folder. So if you go to your Windows Microsoft.NET Framework folder here, and in here, let me just jump down to M at least, we should have mscorelib.dll. We can just copy that. We can go to our project here. Let's go to demos, tutorial token, bin, debug, paste that in there. And then we can take this and we can build it. And you'll see right away, build succeeded. Great, problem solved, right? Well, no. If we look at our output, we had 0 succeeded, 0 failed, 1 up to date. The reason for this is that Visual Studio thinks that the code that we have here is fine and it matches with the DLL. So if it were to compile, it would just output the same DLL it already just compiled. So why do that work? So this is a little efficiency thing here. The thing is that the Neon compiler needs to do other work. It failed. So the simplest way to do this is just take your project and rebuild it. So that'll cause Visual Studio to just force recompiling that DLL no matter what. And then you'll see that our compiler ran, it found the entry point, and generated our APM. So let us deploy this contract here and do a few tests. Invoke, close, advanced, invoke. Sorry, I should wait a second here. So we're at block 42. We should just wait for block 43 to appear. There we go. Is that not it? Maybe it did slip in as well here. Let's wait one more block here. You do spend a lot of time waiting when writing Neo contracts, I find. There are some ways to rapidly develop. I'll try and cover those in a later video. So we're going to call our deploy method and wait for that deployment to complete. Actually, I'm just going to expand this window a little bit. So I'm going to wire up some transfer methods here. So we'll go hash 160 from ourself to ourself here, and a value of 1. Or sorry, a value of, let's go back to our integer type, of 100. Okay, we see that the deployment complete message did pop in down there. Test it. Invalid from. Isn't that interesting here? Oh, because I screwed up. If the length is equal to 20, I was failing it. So, sorry, we got to walk through this all again. We're at 49 here. So I don't know if I've mentioned this is one of the tricks I like to do, is just deleting the character and re-putting the last character in. Keeps on doing a search. So it beats you having just to sit there, wait, and kind of keeps me busy too while waiting for these blocks to generate here. There we go. Deploy, add, test, invoke, close, advanced, invoke. Paste that back in. Wire up our transfer here. And this is going to be an integer. And hopefully here, let's move this over to the side here. There, we got the message cannot send to self. Great. So let's do a negative amount. We're going to make this recipient just, instead of 23 at the end, 21. It's an invalid amount. Okay. We're going to send, so if that's 1,000, I'm going to send 2,000. So it retrieved the balance of this account here and got the balance here of 1,000, hex encoded, insufficient funds. One thing I want to point out to you here is this message here is the account number here, 23BA, and then it ends in E9. But if you look at the hash 160, it actually starts with E9, but it ends with E9 here. And, oh, sorry, this is my 2, but it would be 23 here. Right, if we look at this one here, we can see 23. So this is actually reversed, which is a big tripping point I found trying to decode this information here. So there, we've done a bunch of checks on here. We could also do our check here to say, well, can we actually send, let's put 23 as the recipient and say 21 as the sender. So R23 is who we have with this wallet here. Test not authorized here. And I guess we should actually demonstrate that it does work and look at the output message here. So we'll send this to 21, add, test. So you'll see here that there was a notify transfer with this information, and I'm going to actually invoke that now. So we'll have to wait a block, but we should see this exact same thing here of who it was from and who it was to, and the amount. So this is what an exchange or wallet implementations may listen to for this kind of event. We could probably just execute this by doing a runtime.notify within our code just as well. But the most examples you'll see will do it via the event. Okay, so you see it did some retrieving of balances, then issued the transfer method. There we go. One thing I want to also show here, I'm just going to pull up this contract hash here. And I had no idea this existed till very recently. If you go into the NeoGUI and go to options, there's a NEP-5 contract list. You can paste in a script hash. If you look under assets, you won't notice anything right away. Sometimes it'll take till the next block. And there we go. We have tutorial token, which is a NEP-5. Here's 999. And we can actually do a transfer of tutorial token to someone else from within NeoGUI. So you don't have to use Neon or other wallets that support NEP-5. NeoGUI does support NEP-5, it's just a little tucked away. So one last thing I want to show you here too is that if you do not like this transfer method being named that, there is an attribute. I believe it is display name. I don't use it myself, but I have seen it in examples here of transfer. And I can rename this to be do the transfer event, let's say. So I can invoke it here, and it's smart enough to rewrite that to be transfer when we do the transfer. I'm pretty sure it's display name. Could be another attribute. Have to look that one up. Another thing I don't think I touched on here, and I will, is you will notice here that we do get a warning that it is a possible null reference exception. You will be tempted to do a check, if transfer is not equal to null, do this method, right? I know we can simplify this, but this actually usually causes the contract to exit by doing this check here. It will always wire up the actions it finds here. This is part of the Neon compiler. It will be looking over and inspecting the IL and saying there's an event. I'm going to rewrite that code basically to be a notify. So actually doing this null check really messes up with that and will exit. So it feels a little wrong to write an event without a null check on it, I know, but you have to fight that instinct and just trust that it will be there. So, and that's it. That is a NEP-5 token done without the optional methods in it. So I hope you enjoyed watching this. I always love feedback, so leave some feedback in the comments, and we will see you in the next video.